Hello friends, welcome back to our online tutorial class. This is for class 8. My dear friends, today we are going to discuss about the geometrical part, chapter 12 from your mathematics book, that is quadrilateral. Friends, we all have some idea about quadrilaterals from the previous classes concept. It's a geometrical closed figure having 4 sides. We can define a quadrilateral in very simple way. A closed figure made up of 4 line segments is called a quadrilateral. That means a quadrilateral has 4 sides and they form 4 angles by joining in pairs. Here we have some quadrilaterals. We have different types of quadrilaterals here. But in this class, we are not going to discuss all the different types of quadrilaterals in details. No. We are only going to discuss the parts and components of a quadrilateral with some properties. So let us begin our today's class where we will learn the parts and components of a quadrilateral. As you have seen in the figure, ABCD is a quadrilateral. Here we have 4 sides, that is AB, BC, CD and AD. These 4 line segments are the 4 sides of the quadrilateral ABCD. Now, what are the points A, B, C and D called? Here, the points A, B, C and D are called vertices. A is a vertex, B, the point B is another vertex, C is a vertex, D is a vertex. Vertex means the point at which the 2 line segments meet or 2 sides meet. The point at which 2 sides of a quadrilateral meet is called a vertex. So we are having 4 vertices in a quadrilateral, that is A, B, C and D. Now angles. You can observe in each vertex there is an angle. At A, the angle is BAD, or you can say the same angle is DAB. Another vertex B, at this vertex the angle is ABC or CBA. At C, angle BCD or DCB. At D, angle CDA or ADC. So from here we have understood that in a quadrilateral there are 4 sides, 4 angles and 4 vertices. Okay. Now, diagonals of a quadrilateral. The line segment which join the opposite angles of a quadrilateral is called a diagonal. That means a diagonal always joins the opposite angles. In this quadrilateral ABCD, join angle A and C with a line segment, that is a diagonal. Similarly, we can draw another diagonal by joining angle B and angle D. So my dear friends, in a quadrilateral there are 2 diagonals at the most, and these 2 diagonals always intersect within the quadrilateral. In the figure, the diagonals AC and BD intersect at O within the quadrilateral. Now we are going to understand the types of sides and angles in a quadrilateral. So there are 2 types of sides in a quadrilateral: adjacent sides and opposite sides. When 2 sides meet at a point, then these 2 sides are called adjacent sides. That means if 2 sides have a common vertex, then these 2 sides are called adjacent sides. In the figure, AB and BC are adjacent sides. AB and BC are adjacent side. Why? Because they meet at the vertex B. Similarly, BC and CD are adjacent side because they have the common vertex C. Okay, CD and AD and AB are adjacent sides. So, adjacent side means the two sides will have a common vertex. Next point, opposite sides. The sides which are not adjacent, interesting. The sides which are not adjacent, that means AB and DC, they don't have a common point, they don't have a common vertex to meet. Okay, so they are opposite. Similarly, AD and BC are opposite sides. So the sides which are not adjacent are opposite sides. Next, adjacent angles. Two angles are said to be adjacent angles if both these two angles have a common arm. If the two angles stands on a same arm, then these two angles are called adjacent angles. Here angles BAD and angle ABC stands on the same side, that is AB. That's why these two angles are adjacent angles. BAD and ABC are adjacent angles because they have a common arm, that is AB. Similarly, angle ABC and angle BCD are adjacent angles. Similarly, which two again? CDA and BAD. CDA and BAD are also adjacent angles. Now opposite angles. Angles which are not adjacent are opposite angles. That means the angles should not have common arm. The angles should not have the common arm. These two angles are called opposite angles. Here, which two angles do not have common arm? Here angle A and angle C, you check, they do not have a common arm. So they are opposite angles. Similarly, angle B and angle D are also opposite angle as they don't have a common arm. So clear? Now we are going to learn one of the property of a quadrilateral, that is angle sum property. The property states that the sum of the angles of a quadrilateral is 360 degree or 4 right angles. That is, in this quadrilateral ABCD, angle A plus angle B plus angle C plus angle D is equal to 360 degree. That means the sum of the 4 angles of a quadrilateral is 360 degree or 4 right angles. The proof of this theorem is really simple. We can prove the theorem just by drawing a diagonal on the quadrilateral ABCD. Here in this quadrilateral ABCD, we have drawn the diagonal AC. Now you can observe that the diagonal divides the quadrilateral into two triangles. The triangles are triangle ABC and triangle ADC. If we separate these two triangles, we can observe that the sum of the angles of triangle ABC as well as the sum of the angles of triangle ADC is 180 degree. That is according to the angle sum property of a triangle. Now, the sum of the 4 angles of a quadrilateral ABCD is equal to the sum of the angles of triangle ABC plus the sum of the angles of triangle ADC. Now, sum of the angles of triangle ABC is 180 degree. That angle you just place in place of sum of the angles of triangle ABC. Similarly, the sum of the angles of ADC is 180 degree. That one also you place in place of sum of the angles of triangle ADC. When we add up these two, then we will get sum of the angle will be 180 degree plus 180 degree, it is equal to 360 degree. That means the sum of the angles of a quadrilateral, that is angle A plus angle B plus angle C plus angle D, is equal to 360 degree. So this is very interesting and very easy to understand. I hope you have understood this.